Hello, this is Jason Clement, Technical Sales Manager at Isonas, and welcome to the Certification Training Module. This module will cover a Isonas PowerNet install. Our course objectives are to cover the typical installation tools needed for an Isonas install, review the PowerNet jumper and wiring configuration, review some basic wiring and electrical concepts, cover the basic of wiring devices to the PowerNet, and cover wiring of multiple devices to the PowerNet that are commonly used. So let's talk about some of the Isonas install tools. First off, we'll need a multimeter. We'll use this to check voltages, open shorts, etc. So if something's not working correctly, we need to make sure that the voltage is applied or that the circuit is open or shorted depending on what we need. Basic Ethernet cable tester that can do a cable test or PoE test. This way, if our PowerNet is not functioning correctly, we can make sure it's receiving the correct PoE, or we can check to make sure that the cable is actually functioning correctly. Remember, in our networking overview, we discussed layer 1, and a lot of the problems start at layer 1. When you start punching down hundreds and hundreds of Cat5e, Cat6 cables, eventually you're going to make a mistake, and the cable tester can help locate that. Silicone caulking for exterior PowerNet units. Once we put that on the wall, we want to make sure that we put a thin layer of caulk around there to stop water and moisture and other things from getting behind there. Dielectric silicone grease, or Dow DC-4. This is for protecting the electrical connections. So our RJ45 and our pigtail that are coming down and connecting, especially on an exterior door, we'll want to make sure that we put a little bit on there to protect those connections so they don't corrode. It's always handy to have a dumb PoE injector. A lot of the switches now have smart PoE, so they're negotiating how much power they send out there. And if you start having issues, just go out there, unplug it from the switch, plug your PoE injector in, and then see if the PowerNet comes up and acts normally. Straight through and crossover cables, again, layer 1, you never know when you're going to have a problem. Even I've seen bad patch cables come right out of the bag from the distributor. It's just one of those things that once in a while you're just going to get a bad one. So if you run into a weird problem, replace the patch cable and see if that solves it. Spare PowerNet and pigtail. In theory, again, a pigtail should never have any issues, but you could always run into a bad wire or something that may be inside there, or a bad connection on the pigtail, so that you have a spare pigtail to replace it and a spare PowerNet to troubleshoot. Always remember when you're installing the PowerNet reader controller to install the optical tamper sticker. So let's take a look at the basic PowerNet configuration and the jumpers on the back. We have JP1 and JP2, and depending on how we set these will depend on how the PowerNet handles different types of power, internal power, external power, etc. So if we're taking power from an external device, either 12 or 24 volt DC, we'll have to set our jumpers accordingly. If we're using external power to power the lock and using the relay on the PowerNet for that purpose, we'll need to set the jumper accordingly as well. If we're using PoE, we'll need to set those jumpers for that as well. When the unit's PoE powered, 12 volt DC power is supplied on the pigtail when you set it to the jumper configuration that says C note 1, where we're across pins 1 and 3. That just means that on the red and black wire, the PowerNet will provide 12 volt DC for peripheral devices. Supply internal 12 volt DC to relay common. So this is when we're using PoE and we want to provide power to the lock straight from the PowerNet reader. If we're using an external door kit, we must set the jumper to the setting on JP2 or else the external door kit will not work. Connecting the ground to relays common contact is not used too often, but if you need to use it and you understand it, then you can set the jumper there as needed. This is just a quick review of the Pigtail Overview that we discussed in the PowerNet hardware. Now let's take a look at some electrical concepts here. What is a normally closed contact? A normally closed contact is closed or shorted in a normal state, and when it opens, it's an alarm state. When multiple normally closed devices are wired to one input, they are wired in series. For example, if you have multiple doors that are controlled by one PowerNet, you'll wire the door contacts in series. When one of them opens up, it creates an alarm. A normally open contact is normal when the circuit is open and closed or shorted in an alarm state, so the exact opposite of a normally closed contact. When multiple normally open devices are wired to one input, they are wired in parallel. For example, if you have multiple exit devices that are controlled by one PowerNet, you'll wire those in parallel. When one device closes, it will cause an alarm condition. A Form C relay is a typical relay commonly used in the security industry and in fact in many other industries as well. There is a trigger that changes it from one state to the other. So we have a common, we have a normally closed, and a normally open. So just as the name implies, the contact is normally closed. When the trigger event happens, it'll switch that to the normally open side. Intrusion devices like motions, glass breaks, etc. have Form C relays on them for alarm outputs. When the alarm triggers, the output changes from normally closed to normally open. The PowerNet has a Form C relay built in. The jumpers control if lock power is internally applied. So we saw that we can set the jumpers to either internally apply 12 volt DC when we're powered by PoE to that Form C relay, or we can route external power through that relay if we have an electric lock that takes more than the 600 milliamps that we're providing. There's a couple of common forms of Form C relays. A wet relay where the power is applied internally, such as on our PowerNet where we're using PoE and providing 12 volt DC directly to the Form C relay. Or a dry relay where no power is applied unless externally applied to the relay. TTL outputs or transistor logic. A TTL output is a low voltage, low current output. So unlike the Form C where we can actually route power through it, this is totally different. It's just basically giving us a small voltage that's at a very low current to trigger something else. It's typically used in conjunction with a module to provide a dry Form C relay. On an Isonas device, the TTL acts as follows. When the output is inactive, there is 5 volt DC present. When it's active, there is 0 volt DC present. This is typically used with our secondary relay module when these outputs are needed. And we'll see that in later slides. So how does our SRM module work? This shows the inner workings of the SRM module with the TTL output, purple, inactive. There's actually more inside the SRM module, but for the purposes of our TTL training, this will suffice. Our white-red is a common side of the relay. White-yellow is our normally closed. White-violet is normally open. And purple is the TTL trigger that will trigger it from one state to the other. When the TTL output activates, the voltage is reduced to 0 and the relay changes states. This is the wiring for our Wiegand interface module. The Wiegand interface module converts the Wiegand output of a reader, proximity, Bluetooth, biometric, etc., and converts it to RS-232 used by the PowerNet. How this is configured will be discussed in later modules. But basically we're taking our power from our PowerNet, applying it to the WIM. Our white and yellow wires are our RS-232, and then our Wiegand device will tie in our data 0 and data 1, which is a common Wiegand interface, and then our black and our red power will tie onto the WIM as well. We have to be careful with power here because we're powering both the WIM and an external Wiegand device, and most likely at least an electric lock and other peripheral devices. Just remember that we only have 600 milliamps to work with for all these external devices, and if you're using the WIM module, you may need an external power supply. Important, the keypad on the PowerNet is considered an external serial device. So if you're using a keypad proximity PowerNet combo and you're using an external Wiegand device, the keypad on the front of that PowerNet will not operate. So let's take a quick look at our basic PowerNet reader controller powering an electric strike. So we have our PoE equipped network switch, our Cat5e or Cat6 that's providing PoE to the PowerNet reader controller. Off of our pigtail, we'll tie our tan and black wire across the electric lock with our back EMF protection diode. It's always important to tie the blue wire off to black if you are not using a door contact. This way it will not read the door as always open. This is the most basic setup. This is using a PowerNet to unlock a door, and that's it. Typically used when a company just wants to replace brass keys, but not really monitor door contact status or anything else. This is a very basic magnetic lock setup. Again, we have a PoE equipped network switch providing PoE and Ethernet to our reader controller. Off of our pigtail, we're tying into our magnetic lock. And again here, we're showing the blue and the black shorted so that our door contact is not showing open status if it's not installed. And then we have power routed through one REX device. Now this is a very simple diagram. In a true magnetic lock install, we would have 2 request to exit devices, and in later slides we'll see that. This is a diagram showing 12-volt external power supply powered to the PowerNet. The concept for external power is similar to PoE, except instead of the PowerNet providing power on the red and black leads, we're taking an external power supply and we're providing power on those red and black leads to the PowerNet and any peripheral devices at the door. Make sure that you set the jumper pins correctly and install the correct protection for the lock. So here we're providing power on the red and the black, and we're still using our gray or tan wires to tie in directly to the door lock. This just means that we're basically providing that power straight to the relay on the PowerNet itself. Now if we have to use external lock power, the PowerNet can also be configured to use that lock power as a dry relay. In this example, the PowerNet is using PoE power, but we need an external power source for the lock. So if you see, again, basically inside our PowerNet, it's a Form C relay. So we'll be providing power on the pink wire, which is our common side of the relay. And then depending whether we have an electric lock or a magnetic lock, will be coming off the normally closed or normally open side of that relay. Remember, on the PowerNet, the relay is rated at 2 amps at 30 volt DC. This can be used for locks that use separate power supplies and the PowerNet is triggering an input on their power supply. So electrified exit hardware usually has a very high inrush current of over 15 amps. So they have their own dedicated power supply. So in this case, we would use the Form C relay, but we just wouldn't apply any additional power to it. We would just use that relay to trigger an input on another power supply. Note, typically you'll use either the gray wire or the tan wire, but not both. And as we can see, we're either going to have 12 volt DC on a normally closed side of the contact or the normally open side of the contact. Door sense monitor or door contact. The PowerNet requires the door contact to be normally closed. Here we see a single door contact tied onto the system. Remember, if we have multiple door sensors that are normally closed, we'll wire those in series so that any one will open the circuit. Important, if you are not using a door contact, then you must permanently ground the door sense input to the black wire so the system will not see the door is open constantly. A request to exit and auxiliary inputs. The PowerNet requires the request to exit and auxiliary inputs to be normally open. The REX input expects a momentary closure which will unlock the door and allow egress without setting off the alarm. In DB Crystal, we can set the door to no unlock if this is needed. In some of the further examples, we'll see why we would need to turn that on. The aux input can be used for various functions. For example, we could use the aux input to tie to a button in the secretary's office for a temporary door release. In our review of the PowerNet hardware, we saw the exterior door kit and why we would use that. So basically, we're sending an encrypted signal between the PowerNet and the exterior door kit to unlock the door. Here's an example of our exterior door kit and PowerNet PoE. So we're taking our tan and pink wires, which are tied to our Form C relay inside the PowerNet, and our red and black, which are 12 volt DC power. On the other side of the exterior door kit is basically power supplied and a Form C relay. In this example, since we're using the PowerNet PoE, we're routing the power through the exterior door kit onto the voltage plus. There's a power jumper that takes that positive voltage and ties it onto the common of the relay, and then out to your electric lock, whether it's an electric strike or a magnetic lock. Always remember to use the proper protection for the electric lock that you're using so you don't damage any of the internal circuitry of the Isonas equipment. So we can also use our exterior door kit with external lock power. Between the PowerNet and the EDK, we're going to wire it the same. On the EDK side, we're going to remove that power jumper as we don't want the power that's being used by the PowerNet to power the lock. We're going to install our own power supply. In this example, we have a 24 volt DC power supply that we're tying to the common side of the relay, and then our lock is tied to the normally open side. This is a simple example of using a PowerNet and a TTL output to trigger a door alarm at the door using a power supplied by the PowerNet to the PoE. The purple lead is our trigger to the SRM. The black and red are our positive and negative power. We tie on our door alarm to the other side of the SRM, and when the TTL triggers, it allows power to flow to the door alarm. We discussed briefly in previous modules how the PowerNet and the SRM can control 4 different locks. This is an example of the wiring. Basically, we're using the TTL logic depending on which TTL is active and which TTL is inactive to control which lock opens at what time. So if we have 4 different lockers, each with one person that has access to that locker, each person will be able to read their card and then press the number associated with their locker and only be able to access their actual locker. In order for this to work, you must have the integrated keypad option on the PowerNet. The full knowledge base article is available for download in this module or on our website, which will step you through exactly how to wire it and how to program it through DB Crystal. This drawing is a typical PowerNet with an electrical strike. So starting at the top with our electrical strike, our tan wire and our black will tie on to our back EMF diode, which will go to our electric strike. Remember that electrical strikes are fail-secure devices in most cases, so we need to apply power in order to unlock the door. Our door contact will be a normally closed device, which will tie onto our blue and our black lead. And then our request to exit motion will be powered by the 12 volt DC provided by the PowerNet, and then the green and the black will provide the contact closure that we need to trigger the actual request to exit device. So upon entering, a person will read their card and if authorized, gain access through the door. Upon exiting, the request to exit motion will trigger, shunting the door contact, allowing for the person to exit without causing a door alarm. This is one case in which you might want to turn off the request to exit, triggering the door to unlock. In most cases, people can easily egress when the door has an electric strike through a crash bar or a handle on the door. In this case, we'll turn off the door unlock when the request to exit trips and just have it shunt the door contact so that no alarms happen when people are freely egressing out the door. Here's a typical PowerNet with a magnetic lock. We saw in the previous slide that we only had one exit device, but from earlier modules we know that any magnetic lock needs 2 egress devices, one primary, which is typically a request to exit motion, and a secondary, which is usually a timed exit button. So in this example, we're actually routing the lock power through the gray wire, through our exit button, to our magnetic lock. The exit button has a timer built in and needs 12 volt DC to power the internal circuitry so that when you hit the button, it will open the contact for 30 seconds, allowing free egress out the door. Again, our door contact is a normally closed contact. Our request to exit motion is powered by the 12 volts provided by the PowerNet. Our green and black wire are our circuit, and we have our inrush suppressor to protect the PowerNet from the stray voltage from the magnetic lock. This is probably the most complex install that we'll typically run into. This is a PowerNet full magnetic lock with isolated power inside the building. We're still using PoE, but we're using a PoE splitter right inside the door to keep the power isolated inside. So we can see that the Ethernet passes through the PoE splitter to the PowerNet reader controller, but we're taking that 48 volt DC and bringing it down to 12 volt DC to power all the devices at the door. First off, we'll take a look at our power, which would be our red and black wire. We'll pull that off of the PoE splitter and tie it onto the red and the black on the PowerNet pigtail. Through one of those leads, we'll also put a fast-acting fuse in case somebody does pull the PowerNet off and tries to short the power, thereby disabling the power to the magnetic lock. We're still going to use our EDK, so our pink and our tan will go to the EDK. We'll also need to supply 12 volts to the EDK from the PoE splitter. That will also provide our lock power, which we can see is being routed through the EDK, through our push to exit button, to the request to exit motion. Now in previous examples, we've used the request to exit motion to tie to the PowerNet reader controller, which will then unlock the door. In this scenario, we have a request to exit motion which has 2 relays and a timer built in. So we can route the power through the request to exit motion and set the timer for 3 to 5 seconds so that when it triggers, it allows people to egress out the door, but does not allow somebody to tamper with a PowerNet reader controller and trigger the request to exit. The request to exit motion still needs to be tied into the PowerNet so that it can shunt the door contact while people are exiting without causing alarms. Also, in this scenario, we show a fire alarm relay right at the door to drop power to the magnetic lock on any general fire alarm. Our door contact, again, is just a normally closed door contact. And remember, if we have multiple door contacts, those are normally closed and we'll wire those in series. So to summarize this, in reality, we have 2 power paths. We have one power path for our magnetic lock, which flows through the EDK, through the push to exit button, through our request to exit motion, and optionally through a fire alarm relay. And then we have our static 12 volt DC, which is powering our reader controller, powering the EDK, the push to exit button, and the request to exit motion. So to review our course objectives, we covered the typical installation tools needed for an Isonas install, such as a multimeter, a quote-unquote dumb PoE injector, patch cables, a spare PowerNet, and Pigtail. We reviewed the PowerNet jumper and wiring configuration. The 2 basic settings of the jumper are you using PoE or are you not using PoE, and what voltage input if you are not using PoE. Also remember, if you're using an EDK, you must set the jumper correctly or the EDK will not work. We reviewed some basic wiring and electrical concepts, things like normally closed, normally open contacts, Form C relays, and TTL outputs. Remember, a TTL output is a low voltage, low current output. In order to provide a Form C relay with that, which you'll need in most cases, you must use a secondary relay module. We covered the basic wiring devices to the PowerNet, things like our request to exit devices, which will be normally open, our door contacts, which are normally closed, etc. And finally, we covered the wiring of multiple devices to the PowerNet that are commonly used. Things such as an electric strike, door contact, and request to exit motion, all the way up to the most complex install, which is a magnetic lock on an exterior door, where we have a PoE splitter, exterior door kit, fire alarm integration, and other things tied in there. Remember, in that concept, we basically have 2 paths of power. One that is static power that is always powering the PowerNet reader controller, request to exit motion, and other devices. And then we have our lock power, which is routed through a series of relays on our exterior door kit, push to exit button, and our request to exit motion before it finally makes it to the actual magnetic lock. Thank you for attending this course, and we hope it was beneficial to you. Have a great day.